A building is only as strong as its foundation. The foundation transfers the weight of the building to the ground. A well-designed foundation prevents settling and cracking. This ensures the building remains stable for years to come. The foundation must be strong enough to support the building's weight. It also needs to withstand environmental forces like wind and earthquakes. A weak foundation can lead to structural problems and costly repairs. Column footings are a common type of foundation. They support individual columns, which carry the building's load. These footings distribute the weight over a larger area of soil. This reduces the pressure on the ground. Column footings are typically made of concrete. They are placed below the ground's frost line. This prevents movement due to freezing and thawing. The size and shape of the footing depend on factors like the column load and soil type. Several factors influence the design of column footings. One crucial factor is the load-bearing capacity of the soil. This refers to the amount of weight the soil can support safely. The type of soil also plays a significant role. Different soils have varying strengths and drainage properties. For example, clay soil behaves differently than sandy soil. The water table level is also crucial, as it impacts soil stability. Designing column footings is a multi-step process. It starts with determining the load on each column. This includes the weight of the building itself, known as the dead load, and the weight of occupants and furniture, known as the live load. Next, the engineer calculates the required footing size based on the load and soil capacity. They then determine the depth and reinforcement needs of the footing. Finally, they produce detailed drawings for construction. Section 5. Material selection for column footings. Concrete is the most common material for column footings. It is strong, durable, and readily available. The concrete mix needs to be carefully designed. This ensures it can withstand the imposed loads and environmental conditions. Reinforcement is often added to the concrete. This increases its tensile strength. Steel rebar is commonly used for this purpose. The type and amount of reinforcement depend on the footing size and load requirements. Section 6. Illustrative examples and practical insights. Let's consider an example. Suppose we are designing a footing for a column supporting a second-story bedroom. The calculated load on the column is 20 tons. The soil at the site has a bearing capacity of 2 tons per square foot. In this case, the footing needs to have a minimum area of 10 square feet, 20 tons divided by 2 tons per square foot. A square footing with sides of 3.16 feet would suffice. This example illustrates the direct relationship between load, soil capacity, and footing size. Section 7. Benefits of proper footing design. Proper footing design is crucial for the safety and longevity of a building. It ensures the foundation can support the building's weight without excessive settlement. This prevents cracks in walls, floors, and ceilings. A well-designed foundation also provides a level base for construction. This makes the building process smoother and more efficient. Moreover, it reduces the risk of future foundation problems, saving on costly repairs. Section 8. Common mistakes to avoid. Several common mistakes can occur in footing design and construction. One mistake is underestimating the building's load. This can lead to an undersized footing that may fail. Another mistake is ignoring the site's soil conditions. Using an inappropriate footing type or size for the soil can lead to settlement and instability. It's crucial to have a qualified engineer design the foundation based on accurate site conditions. Section 9. Conclusion. Building on solid ground. In conclusion, the design of column footings is a critical aspect of constructing a two-story building. A thorough understanding of soil conditions, load calculations, and material selection is essential for creating a stable and durable foundation. By following the steps outlined in this essay and seeking expert advice, you can ensure your building stands on solid ground for years to come.